Okay, so for the benefit of the recording, welcome to the Code Along in week 5, where we're looking again at the Tidy Tuesday data. So I'm going to share my screen in a minute. This week's Tidy Tuesday data is about pumpkins. It's about people who grow very large pumpkins. So it's vaguely Halloween themed. It's a bit early for Halloween, but we've got something specific to the lecture material for next week. So we'll have to go early with Halloween. So, I mean, if you go in the shops, they're all Halloween themed already, right? So let me share my screen. I mean, if you go in the shops, they're all Christmas themed already, but we're not going that far yet. Here we go. So hopefully you can see that. If it's a little bit fuzzy, as usual, Zoom can take about a minute or so to resolve properly. As far as I know, my internet is working fine today. But if there are any problems with that, I do have backups ready this week. So anyway, the data come from the Tidy Tuesday project. The website that's collated them is called bigpumpkins.com, and they're providing data from the Great Pumpkin Commonwealth. When I was preparing this, I learned that there is a way bigger subculture about pumpkins than I had ever realized. So let's have a look at the data, shall we? So we need to run our library tidyverse as usual, and we'll load our data. And here is our data set. This is a lot of data. So we've got our ID column, which annoyingly doesn't seem to be functioning as an ID. So normally ID as a column would have a unique entry for each row, but this clearly doesn't. I think it might be like a competition ID. The data dictionary is, we can look at the data dictionary, I think. So let me go on, if I knit this. Oh, forgot to do the, yeah, there we go, preview and viewer pane. Let's knit that again. So if I knit this and go to the Tidy Tuesday page, it will insist that I open it in a new window. And it says the ID is year type. So I think that's like to do with what kind of competition it was. But then we've got
Can I just put in as well? As part of the project, we're asking you create a data dictionary as well. So it's worth a look at what data dictionary.
Yeah, I think either David's breaking up or I am. But someone put in the chat if it's me. But the not me. Okay. What was I going to say? Yes. You can have a look at data dictionaries on, for instance, the Tidy Tuesday things all have data dictionaries. The data here as well, we've got the place, what place they came in this pumpkin growing competition. So these are data from competitions. Todd Ellenbecker and Sequoia came first in this particular competition with their pumpkin that was 150.5 pounds. This is American often, so it's measured in pounds. It sort of says which country they're from. It talks about the mother and father of the pumpkin. And then it talks about, this is the OTT is over the top. It literally means over the top. But in this case, it means measurement of the pumpkin over the top of the pumpkin. Est weight is the, let's just get rid of the sorting there. Can I unsort? No, I can't. I need to go all the way over here and do that. There we go. Est weight is the estimated weight of the pumpkin from the over the top. So maybe we could do something with that. We could look at how good the predicted weight is compared to the actual weight. And PCT chart, I didn't actually remember what that was. So let's just go to our data dictionary again. So that is percent on chart. That's not helpful. This isn't the best data dictionary, as you can see, because it's not actually telling us what some of these things mean. and variety of pumpkin. The types in the ID column are the types of pumpkin. So field pumpkin, giant squash, giant watermelon, long gourd, in which case the value is not the weight in pounds, it's the length in inches, and T is tomato. Okay, so let's do a sort of first thing. So the first thing I'm interested in is which countries are most likely to appear in this data set. Let's make a code chunk. If we want to find out which countries most appear, what kind of graph might we use for that? What kind of diagram? What kind of diagram could be used to show? Yeah, bar chart. Yeah. So we're going to do a pumpkins. We'll do ggplot as usual. I'm going to warn you, by the way, this isn't going to work. I've tested this. We're going to need to do something later, but I just want to show you what happens if I try this. So ggplot. Let's put the values going across on the x-axis. So we'll have y represent the country. And we'll do a jump bar. Nice and straightforward, and we'll watch as this completely fails to work. Ta-da! Okay, so something's gone weird here. So firstly, we've got unknown country at the top there. So that's, you can just about see, it's not very clear. So that really we'd want to be coded as NA probably. But then we've got all of these things down at the bottom, which look awful. So let's see, all of them seem to start with things that aren't letters. So I'm going to use something that you haven't quite seen before to do this. So what I'm going to do, but you will see it soon. What I'd like to do is filter, run some code that will, and this is kind of temporary code. I don't really care about this. I'm probably going to get rid of it in a minute. But I want to filter for which lines don't start with a letter. So for that kind of question of what kind of a letter, we're going to need something called regular expressions, and you will sort of see these a little bit, but there's a little code for doing a string match for things that don't start with a letter. I'm not going to go into what that is. I'll just type it. And I'm going to have to just cheat 1 second and look this up myself. Oh, that's my edge. There we go.
Is this like a Blue Peter, here's one I made earlier sort of job? Or are you going to show us?
No, I'm actually just looking at I have got a here's one I made earlier.
If you can show us what you're looking up.
Yeah, sure.
Yeah, show us how you're finding this information.
Yeah,
it's useful for us to see.
So I'm looking up the I'm just going to say I don't normally use Bing, but I'm using Edge for this because I've got Firefox already. But there is an R like regular expressions cheat sheet somewhere, and I'm just trying to find it. So when we that looks like that's the one I wanted, I think. So I just found that on the internet, and it's telling me that the thing I want, there's lots of these like this. So I want the start of the string, and then I want something that is I want to check for a letter at the beginning. So have we got anything that does that? Alphabetic characters, there we go. So it's square brackets, colon, colon, alpha, colon, square brackets. So that's what we're testing for. So what we want in our, going back to our thing, so going back to Firefox, we're going to want pumpkins, filter str. Will we need to reference cheat sheets not provided by the course? Not if they're just dictionaries of code. No, if you're referencing someone else's code, then yes. If you're just looking up like what functions do what. Yeah, so we can use, what we're going to use is str detect for that. Yeah, so the reason I'm not just checking for number is there seem to be some weird things going on with brackets. So that's why I'm doing sort of the opposite, and I'm doing str detect. And I'm interested in whether the first character, so that means match the beginning of the string, so something at the beginning, and I want this. And it's not happy with me. Why isn't it happy with me? Oh, because I haven't told it what to detect in. There we go. Country. Looking good. So now we have some entries here that where the country doesn't begin with a digit. So that's a bit hard to see. I'm just going to run a view so that I can actually see this. And this isn't looking good. Every row, every entry in all of these rows is exactly the same. And I think what's happened here is this has been loaded from an Excel file where there've been like rows that are certain things that kind of cells that are merged across columns and like as header rows. And somehow those have ended up in our data set. So we don't want any of those. And actually, I think we can check that we can be a bit more specific. In fact, the brackets are misleading. Everything here is starting with a number. So the code for number, by the way, is \\d for a digit. So what we actually want to do to clean our data set is we want the ones that don't start with a digit. So if we do that, well, that's not working. What's going on here? CSV files are, it depends what you're trying to do. Oh, should be a lowercase d. Capital D is aimed at not a digit. So what str detect does, so we can have a look at our, and yeah, storing your data, generally CSV or RMD files are better. No, not RMD, RDS files. And we'll talk about, those appear in one of Mina's videos talking about the difference between why you might use one or the other. Yeah, so David's just sent the link. String detect is detecting whether or not a particular string is there. And this is, so this can just be a string. So this could be like United States, and it would return true for anything that had United States in it and false otherwise. And then we've put the exclamation mark at the beginning to flip the results. What I've done here is given it something a bit more complicated, which means match, this represents the start of the string and this represents a digit. So it means this is matching if there's a digit at the start of the string, and then this is flipping it, so saying anything where there isn't a digit at the start. And that gives us countries. So this is looking better. So we've got somewhere, but I'm also going to use a mutate, because one thing I said before was that I'm not happy about the fact that, so let's just see what happens when I pipe this into a ggplot, just so we can check. Helps if I spell ggplot right. There we go. So that's a lot better now already. But we've still got this unknown country at the beginning. I don't really like that. I'd rather that be NA. And we've also got the Netherlands, which is fairly non-standard. Normally in data sets, you just say Netherlands. So I'm going to fix both of those. So what I'd like to do is mutate, and I'm going to replace the country field with, use a case when, because I've got 3 different cases here that I want to fix. So I want to map, if the country is equal to unknown country, I want an NA. If the country is equal to the Netherlands, I want Netherlands. Otherwise, so we can use just true here. So otherwise, I want it to just be whatever it was before. So you'll notice that I haven't put a pipe there. So that means that this is only going to run up to the end of the mutate statement.
Alex,
Yes.
can you just explain why you've left such a large space after true? Isn't that going to affect the code?
Yeah, good question. So the reason I've done it is that is neater. So R just basically ignores spaces in most contexts. The reason I have done that is so that all of these tildes are nicely aligned. So it just makes the code more readable. So it's very similar to indenting. So one thing that people lost marks for on the homework, not many marks, but a couple of marks at the end, there were marks for style. And if the indentation was a bit all over the shop, or if there was not a new line after a pipe, or spaces around operators, so like a space either side of this tilde, or really, really long lines that haven't been broken up, then that could lose marks. So that's there are two reasons why I've broken, done the line break here. One is because it makes it neater, and the other is because it would be a really long line that I have to scroll sideways to read.
Yeah, I agree. I think that looks pretty nice, and then you can compare the two columns to see what the kind of statement is that you're trying to use, and then what happens if that's true or false.
So it's a similar thing that people might do with there's a function often used to make really basic data sets called tribble. I don't know if you've seen Mina use this, but to make like sample data sets. And again, you're sort of essentially typing a table there, and then you want to make sure it lines up neatly. But actually, this function isn't going to work. There's a really subtle mistake in here, and I wanted to talk about it because I think other people will come across this if they try and use a case when X must be a logical vector, not a character vector, and it's not happy with something.
What do we think, folks?
Any ideas?
See? Yeah, this is a hard one. This is a
really hard one, and it took me a bit of thinking. So I'll tell you what I did here. And what I often do, and in fact, often when you ask me questions on Piazza and there's an error message, what I often do is Google the error message and look on Stack Exchange. So don't be afraid to Google error messages. Often they're if they're hard to interpret, often they're very specific to a particular function, a particular problem with it. But can anyone see? So I'm going to give you a hint here. Yes, very good, very good. I don't need to give a hint. So someone in the chat says NA is logical, while the ones in character marks are character. Yeah. So the problem is that you can mix NAs and characters in a vector, but by default, NA is a logical thing. And I've put NA first there. I think it's not helping. So what is not happy with me is when I say, actually, if the country is the Netherlands, change it to Netherlands. It's saying, oh, but you've just told me you want this new column to have it like logical things in NA, and which is what it defaults to. And you've just given me a character. I don't like this because columns of a data frame and vectors have to only contain one data type. They can only contain strings or only contain logical or anything like that. So it turns out the solution to this, and the reason I wanted to talk about this is that you might come across this and I just want to show you. So NA underscore, if you type that in, you get all these different options. And these are different types of NAs for different types of data. So here we want NA character because we've got characters everywhere else, and this is now going to work. So there you go. So now let's pipe that into the ggplot, and this is looking a bit better. There we go. So we've now got an NA column at the top, and we've got our Netherlands there. So we can't use NA by default here because it's assuming that that is a logical, so a true false statement. And because we're trying to actually make this a character vector, it's giving an error. So we're trying to make a new character column, a new text column. And it's telling us, oh, you're mixing variables. You've just told me that you want this column to contain NAs, and you didn't tell me anything else. So it's a logical thing. It must be. That's all you want, true or false. Oh, but you've now given me text. I don't like that. So we have to actually explicitly tell it in this context. Oh, why can't we use just quotes? We could put a blank string. NA, though, is handled neatly by a lot of different things. So if we wanted to do like an na.rm something, we could easily do that. whereas like there are functions that handle NAs really neatly, whereas they don't handle blank strings very neatly. So we tend to want to explicitly encode our lack of data as lack of data. Okay, so and why do we need the truest country? Well, good question. Let's find out what happens if we don't put it. There is only one country now, and it's the Netherlands. So what's happened there is if something doesn't match any of the statements, it just puts an NA in. And what we actually want is if it doesn't match any of those conditions to just go back to what it was before, to keep what it was before. There's an excellent XKCD talking about the Netherlands taking over the world. Strongly recommend. It's got nothing to do with this code along, but it just reminded me of it. It involves draining the oceans and then going into all of the seabeds and stuff. It's fun. Anyway,
if you're familiar with other styles of coding, it might be helpful to think of case when as like the first line's if, then there's if else on the second line, and then the last line is like else. So in other words, your first statement is what your logical is, and then that very last bit, then you have all your other statements, and then the last bit is like, and what happens if nothing else matches, then do this. And in this case, it's just keep the country.
Yeah, and you can use, there are if and else ifs here, but this is just a sort of neater way of doing it when what we want to do is to replace one thing with another. So to sort of mutate. Why can't we use conditional statements? I think because it doesn't work very well with vectors, necessarily conditional statements. Because what we want here is kind of different cases. We want to take different possibilities for each one. And conditional statements in base R, we'd have to then loop over each element of the vector. And that's just less neat. And you would use if else instead of case when. If else is a slightly neater syntax, I think, because you just specify a thing and then what happens if it's true and what happens if it's false. You would use if else instead of case when if you only had two conditions. So if it was true or false. So that's why we used if else in some of the stuff with the homework, because it was just, is it a weekend or not? Whereas here we have three things that we want to test for. And we had to mutate, because what we were doing, we wanted to replace the existing country vector with a new one. And yeah, we did. You can nest if else statements. I think, yeah, you could nest them, which is essentially how you have to do it in Excel, I believe. But yeah, you can nest if else statements if you want to. I'll let David handle a few more of the questions in the chat, but just linking to what I was going on about earlier, so I'm not talking utter nonsense. So the next thing I'd like to do is, well, firstly, what I want to do, I've now cleaned up these data a little bit. So I'd like to save this as a cleaned data set. So let's do that, pumpkins cleaned. And I'm breaking the pipeline there, because if and this is another thing I saw when looking at people's homework and stuff. If I did this, what would happen? If I just ran that code, that pipeline from line 30 onwards, what would happen? Any thoughts? What would I store under the object? What would the object pumpkins cleaned be? I'll give you a hint by running it. It's a list of 9. But yeah, the people talking in the chat have got the answer. It's a plot, because we've gone all the way through and it's just this entire, we're assigning this entire pipeline to this object. And under the hood, R stores this as a list of 9, which is why it's a bit confusing. And if we click here, that doesn't look like anything. But if I actually just type pumpkins cleaned into the console, it doesn't do anything because we've already got the plot open, but it produces a bar plot. So what we actually want to do is stop here. And then we can make our bar plot from this. Okay, so when we're making the bar plot, I actually probably don't want the NAs in here. So I probably want to filter out. What function do I use to get rid of the NAs? What condition do I need here? Yeah, a couple of questions. So na.rm would get rid of the NAs inside some sort of calculation or inside a plot, but actually what I want to do is filter them out of the data set entirely inside a filter statement, which means we need something that gives a true or false, and the answer then is yeah, is.na. So is.na country, I want to get rid of anything that's an NA country. And it's not happy. Oh, that's because it's because it's still a plot. I had to run that again to make it back into the data set I wanted. So that's looking good. Okay, so now what maybe I want to do is, I mean, already, by the way, we can answer this question. The countries that are most interested in growing big pumpkins are the United States, Canada, and Germany. But how would I, if I wanted to put this in order? So if I wanted to show it so that the United States was at the top, and then yeah, so FCT reorder is one way of doing it. That's one way of doing of reordering factors. But in this case, there's one that's a little bit more apt. So is in freak is the best one, and with reverse, very, very good, very good. So let's just go through those in step. So firstly, what we want to do is we want to do so we have to mutate to use these. And because we're going to do two things, I'm going to do one of these mini pipelines again. So I want to do country equals country pipe FCT in freak. So if I just do that on its own, and I haven't actually put it inside the plot. It's almost there, but of course it's showing them in the wrong order for a horizontal plot, because it's sort of assuming we want the biggest one first. And the biggest one first in the context of this plot means the bottom, because x-axes go up. But actually, the way we look at it, we probably want it the other way around. So FCT rev. Good. So that's looking a lot better. And we could do something similar with the states, and we could see which states were most interested in growing these pumpkins. So I might do that in, yeah, let's do that now, actually. So let's do a which states. So I'm not going to take too long over this. But the first thing I want to ask is, suppose I wanted a new data set of just the, suppose I wanted a new data set that was just the US observations. How would I do that?
Can we see the original data set?
So I just want things that were in the United States. Yeah, filter out everything except the US. Good answer. So what am I going to want here? So it's country, sorry, not country, pumpkins, filter, country equals you. What do I want to put here? What was the phrasing that I need to put here? Will that work?
Are other people slightly behind Alex?
Possibly.
That might be why there's a bit of a delay when you ask a question.
I see.
Put in chat if it's just my end. It could be my computer's being a bit boring today. But
it is United States. We need to get the phrasing exactly. But can anyone spot a mistake with this code? So I'll assign it to Pumpkins USA, which sounds like some sort of, I don't know, company or band or something. But let's say I run that. What's the problem with what I've done there? So actually probably won't cause too much trouble, but it's also not good practice. Any thoughts? No, so we don't need in because we're only testing for one thing. So we use in if we were wanting to see if in would work, but we don't need it here. Very good. I've used the pumpkins dataset, and the reason I'm putting this error in is I made this error when I was prepping for this. You need to use the pumpkins cleaned dataset because we've actually, we've gone to the effort of cleaning up our dataset, and it might be, as a little hint, that we're going to want to modify that clean dataset again because there is something that I'm not happy with in that, which we'll come to. But once we've got a clean dataset, no, so pumpkins clean doesn't still equal a bar plot because I reran this code and fixed it, so it is now back to being a data set. So, so if I wanted to filter for US and Canada, that's a good question. That would be when we'd use in. So it would be country, in, C, United States, Canada. The other way of doing that, which is a little bit less neat but would work, would be country equals United States, or, which is the vertical bar, country equals Canada. Both of those would work. This gets a bit less neat if you start using really long lists. So that's when I tend to use in because it avoids having to type country every time. But we just want country as United States. So let's do that. And then we'll do, so what I'm going to do is just, this is the Blue Peter style. Here's one I made earlier. I'm just going to, because it's exactly the same, but I just think it's interesting. I just want to copy and paste the code. So this is exactly the same thing as we did before, but state prov is the thing we need for this. There are 50 states of the United States, and in fact, all 50 of them are represented in this data set. What could we use to only show some, which there's an FCT function which will let us only show some of the values. Anyone know which one it might be?
If not, can you pull up the documentation and then have a look at the all the ones that are available to us to pick from? That might be helpful. So
I'll put in forcat, which is the name of the package. So forcat is in the tidyverse. If you want to use it, you don't need to load it separately. And we can look at the index here, and we get all of these FCT functions. So does any of them look like it might be what we want to sort of combine things so that we don't have all of them? We just group some of them together. I'm trying to avoid saying exactly the phrasing that's on the screen there. Lump, yes, it's one of the lump ones. So it turns out if you look at the documentation here, lump isn't recommended on its own. They recommend that you use one of the specific ones. And I'm going to use, I played around with this, and the one that seems to work best, I think, is putting an SCT lump n. And the reason that n is better is that actually I think for this, it's kind of worth playing around with different n's to see which one you like. So playing around with different numbers of states that we want to lump together. And for that, having an explicit n of let's keep the first 20 states easier. If we do proportion, we have to kind of guess to, if essentially you want to just visually step through one at a time, adding one more state and removing one state and seeing what happens, it's better to just explicitly do that and to say, okay, we want this many, so we can just increment it by one if you want to separate one more out. So for instance, if I do n equals 25 here, that looks okay. I think that's still a bit too many. So we can now try n equals 20, lump 5 more of them together. But what I don't like is that other is the largest variable. So let's try n equals 21. Yeah, that's looking, I think that might be what I'll go for there, n equals 21. Incidentally, what I was looking for when I was preparing this was a function that would lump together everything. So lump together as many in the other section so that other was still smaller than the largest, so that other was still smaller than Wisconsin. As far as I can tell, there is no function that does that. which means if I ever have time, I'm very tempted to write one. Is there any way to show which states getting lumped into other? Oh, that's a really good question. I don't know. Yeah, I don't know. I'll make a note of that because it might be. That's a really useful thing. Yeah, so here it's relatively easy because it's just the states that are not those ones, and there are 50 states. Could you do the average of the other? You need to do a bit more fiddling around, and it probably would make less sense for a bar chart because a bar chart is sort of counting things. So you generally wouldn't take averages, but yeah.
Could you, with the data, like do the count as a separate thing and then use like a filter statement or something?
Yeah, I guess that would work.
Might be the quickest way to see what's being grouped and what's not.
Yeah, that would probably, yeah. Yeah, filter for the ones that were sort of the opposite of a slice min. It's a slice min, isn't it? Slice min.
Yeah.
You could do it that way.
There's probably a few ways you can do it, right?
Yeah.
Like most things in coding, there's a few ways. There'll just be some that are quicker than others or easier to understand.
Yeah. The reason I wanted to just skip past this a little bit though is I wanted to then say, okay, we've looked at, this is just bar charts. This isn't the most interesting thing, but what I'm interested in is the weights of these pumpkins. I want to know which state produces the biggest pumpkins. Which state is particularly good at this slightly bizarre competition. So let's have a go at doing that. So let's do pumpkins USA. We've got our nice data set. What are we going to want to do if we want to, let's say I want to find out the mean weight of a pumpkin in each state in these competitions. What function do I need to use here in this pipeline? And yeah, excellent. Group by and then summarize. Yeah. Someone asked, by the way, could we increase the size of the plot so all 50 states are shown? Yes, we could. And how would you do that? In an R Markdown document, so I haven't actually knitted my document yet, but there's a chunk option for figure height, I think it is. I forgot.
Put it in chat.
There we go. Yeah, fig.height equals 10, for instance. So that would, in the knitted document, make it bigger. And someone asked, how come FCT in Freak arranges every observation in the same order if it's only being used in state prof? Because FCT in Freak is counting. So the reason it puts them in the same order, it's just counting how many times it appears. So it works in this case because the other variable is count. If I were doing any other sort of plot, it wouldn't. And that's when you use FCT reorder. But someone said, there was a tweet that someone sent me that was something like 90% of all data science is group by then summarize. And they're right. Let's group by state prov it was. And we want to summarize, let's say mean WT equals mean of weight in pounds. What have I missed? Not NA, yeah. Yeah, NA.rm equals true. Oh. Yeah, you see, I thought that was going to fix it as well. And you do need it. You absolutely do need it. But it didn't this time. And it's this again is a really subtle error. But I'm showing you it's the sort of thing you can end up with real world data. So let's go back to our pumpkins clean data set. I'm just going to type it in here for a minute. Have a look at that weight column. That weight pounds column, it's the third column. Do you notice anything weird about it? It's not the NAs and states. There we go. Yeah. So it's interpreted that as a character vector, and that's weird because it shouldn't do that. The reason it has is that when we loaded it, do you remember there were all of those nonsense observations that we had to get rid of? It's found those, and there's sort of hierarchy that R uses. So if there's a mixture of things it thinks are numbers and things it thinks are characters in a column, R says, well, I can't convert these characters into numbers, so I'll have to go the other way. So it's assumed that they're characters. So I tried a couple of things to fix this. And the function, it's another tidyverse function that's really useful here. But we need to go right back, and this is really something that we need to do in our cleanup. So this is another step in our like mutate. We can just put it there. And what we want to do is the function that's useful for us here is one called parse_number. So you can use as.numeric, that would work, except that as.numeric fails here because some of these numbers, when we get down into it, there are some absolutely massive pumpkins in this data set. And there we go. It doesn't know, as.numeric doesn't know how to deal with those commas. So commas here are thousand separators. If anyone hears from well, various other countries, you'll know that there are lots of different conventions for this in different languages, different countries. The convention in British English and American English is to put full stops as decimal points and commas as thousand separators. As it happens, because R tends to, I mean, R was invented by a New Zealander and a lot of the development goes on in America. By default, it often uses American or Commonwealth English conventions. So parse number assumes that full stops represent decimal points and commas represent thousand separators, but you can give it options for otherwise if you were looking at, say, French data, where I think the reverse is true. So if we do that, so, oh, that's in the wrong place, actually. That's doing something as part of a data set. We actually want this as part of our like cleanup mutate statement. So it goes there. And now we need to recreate our Pumpkins USA from our reclean data set and then go here. And now it works. How would I find out which state has the biggest mean pumpkin? What function do I need on the end? Arrange desk, yeah. So arrange desk mean WT. Turns out Delaware. But I just want to add, I want to give a caveat to this. So we've always got to be careful with this with sample size. And it's something I sort of noticed with the homework. So one of the things with the homework is that, and the sort of talking about the district, there were no marks for this, but it was just a thing I noticed. When there was the data with different types of accident, and there were fatal accidents and serious and so on accidents, you could make some comment about the distribution of the fatal ones, but there were, I think, no data. There were like 4 data points of fatal accidents, so it was really hard to make any sort of conclusion about it. And I wonder if something similar is true here. Marks for the homework aren't available for everyone to see, but you can actually see the mark scheme because it's a template in the repository. So you can have a look there.
We said at the start, you might not have been here for it, that we are currently marking it. And the marks, the feedback are essentially released as it gets marked. So we're going to try to get them back within 2 to 3 weeks. But it depends on who's marking. And I shuffled the thing. So it's not like if your name starts with an A, you're more likely to get a mark earlier than later.
And you'll get random people each time as well. So
but you'll start to see it pop up. You should get an email from GitHub when you get it. But if not, then just keep checking it.
Yeah. So what I've done is I've added an n equals n here. That's a bit weird, but essentially what this is doing is roughly the same as the count function. So the n function just takes just counts the number of rows in each group, and we're just going to assign that to the label n. So that n means that one there, and that n means the function n. And now we can see that, yeah, Delaware has the highest mean weight of pumpkin, but it also only has 5 pumpkins. And that's not very many. So maybe Rhode Island is better. It's got 308 pumpkins and they're much heavier. So what kind of plot could we use to display these kind of things? What kind of plot could we use to sort of compare our distributions of pumpkins? Bar plot? Yeah, maybe not for distributions of weights. Yeah, we could facet by state, but what kind of like geom do we want? Yeah, let's a ridge is interesting. Let's try a ridge, but I want to filter out some states because I'm not interested in the states where there are fewer than, let's say, 50 pumpkins. So let me just do that. So we don't actually need the arrange anymore. What we need is filter n is less than or equal, so n is greater than or equal to 50. Oh no, I want to know which ones to remove, let's say. So n is less than 50. Let's do the other way around. There are 16 states with fewer than 50 entries in here. And what I'm going to do is so I think this function comes up in the homework. I'm going to put pull state prov. So what that does is it takes the state prov column and extracts it as a vector. And that's useful because I can say let's say, I'm going to put small states, it's misleading, but I've now got a vector of states that didn't have very many observations. Which means what I can do, if I want let's say my ridge plot, someone said. So for a ridge plot, we're going to need our GG Ridges library, so let's package, so let's put that in there. We're going to want to take Pumpkins USA. And we first want to filter for not the, what we want is that because of the way I've defined this, we want state prov to not be in small states. So I am not actually sure how you do that. I think you might be able to do it. I think
anyone in chat have come
across
this? No? When you have where you're doing not in rather than in?
You could define a nin operator, yeah. But I'm just going to look in Stack Overflow. So yeah, it suggests that essentially you can define an operator, but the easiest way is just to put an exclamation mark around the whole thing. So let's just do that.
It's quite a common one that, and it can be a bit confusing because you got in, and so you assume that there's a not in, but I don't think anyone's made a not in, which is annoying.
You could make one if you want, much as I sort of think I'd like to make, when I have time, the FCT function that does what I was trying to do, which is make sure that the other were less than the smallest entry, which is not something anyone seems to have thought of coding yet. So we want the X to be the weight in pounds, and we want the Y in this ridge plot to be the state or province. And we want a GG ridges. And I'm going to put an alpha parameter on this because we usually want some sort of transparency on a ridge plot. Oh, no, that's the name of the package. I always do this, geom density ridges. Filter does keep values that satisfy the condition. So because we've done I could have just done this the other way around. I realized this would have made more sense. I could have made this large states, filtered for n at least 50, and then kept the ones that were in large states. For some reason, I did it the other way. So let's fix this actually, because that's let's put that there, and then we can just do in large states. That's easier to read. Oh, it's not happy with me. Oh, because I didn't actually run this again. Still slightly too many states, I think, right? Still, you know, there's still a lot of states there. So we could do a thing with the fig height. And when we knit, this might be more legible. Let's have a look. We knew that was that's not supposed to look good. There we go. I still think we probably for this want to do a mutate state prov equals fct rev state prov, so they appear in the opposite order. But Arkansas is crossing with California. Yeah. Arkansas again, just it's not now. It's now crossing with Alaska because I flipped them. Arkansas has a very high density of them. So it's also worth briefly talking about this. In a density plot, the height represents concentration of data. It doesn't necessarily represent a lot of data points because all of these plots, all of these ridges are normalized. So they all have the same area underneath them. The area underneath each of these little density things is the same. And let's say it's 1 for sake of argument. So when something's higher, it doesn't mean that there's any sort of like increasing trend or that there are more observations in Missouri that had this height than, you know. What it means is that the data were more concentrated around a particular value. So Arkansas has just had a really like consistent set of pumpkins compared to, say, Illinois, which has had a much wider spread of pumpkins. One thing I might want to do though, so I've shown them in this reverse order, but one thing I might actually want to do is show them, I'll just make this the last thing because we're close to the end. I might want to show them in order of their medians, let's say, or their means. Let's take them in order of the mean pumpkin. So we're going to need an FCT function, and this is where we use the FCT in order. Yeah, the peaks kind of represent the most frequent values or the most frequent range of values. So it's having to smooth it because these are continuous data, but it's sort of estimating the sort of continuous distribution these things are coming from. And this is the kind of bit where you get the most things. Yeah. FCT in order, and we want to put them in order by weight in pounds. So this is where we have to specify another variable. Oh, not in order, FCT reorder, sorry. So weight in pounds. And we have to specify, so this is now going to look at the weight in pounds function. It will get a range of values, right, for each state. So we want we said we wanted it to be done by the mean of those values. So do it weight pounds, mean. By default, it chooses the median, but let's say we want the mean. Okay, hard to see because of the, oh, and we're also going to want to, oh no, they're actually in order now, right? The highest one's at the top. So let's just knit that now. And I need to then fix the labels, and in the write-up, that's what I'll do. To answer the question, is the concentration relative to the state's number of observations or the number of observations overall? E.g., would a state with few pumpkins, but all very similar weights, have a higher peak than one with many more pumpkins, but over a wider range? Yes, is the short answer. A state with few pumpkins, but all very similar weights would have a higher peak. Yes, it's got really nothing to do with the number of observations because we've normalized it. It's all to do with the concentration. So if you had very few pumpkins at very similar weights, you'd get a very high peak. And with a lot of pumpkins, or even a few pumpkins, but over a wide range, would have a very flat graph. And if we look at this now, we see that the ones with the higher means are appearing at the top and the ones with the lower means are appearing at the bottom. And actually what we're seeing now is the ones with the lower means actually tend to be more concentrated, whereas the ones with the higher means, it tends to be that they still have a peak around the same point, but then they've also got this kind of heavy tail on the right-hand side of extremely heavy pumpkins. I think that's about enough pumpkins for today. I'll do a write-up of this as usual. Might take me a little while. I'm going to stop sharing my screen. Yeah. Thank you for joining as usual. Hope you enjoyed. And
I'll stop the recording now. I guess
Yeah.
stick around if you got any last minute questions
Yeah.
while me and Alex hang around. Thank you very much.